Now what I'm going to do initially is jump into the strawberry RBD, and I'm going to actually isolate one of these strawberries, right? So if we select the RBD solver, come here to the selection tool, and then actually because they're packed I can just select one as they are, hit delete on my keyboard, jump into this blast node. It's like a delete, it's the same, delete non-select, and then I've just got the one strawberry. Okay, and then we can focus on this one to start with. So I'm going to jump into back into my fluid initial, and let's take a look at the actual strawberry so we can get a sense of the size. Alright, so I'm going to bring down the size. We'll bring it down a lot, just to, maybe even more than that. We'll do just one by one for now. Right, just to actually capture the strawberry. Let's just play through that. Actually, let me turn off the collider. We're building that VDB on each frame, which will run slowly. So turn off the visualization and on the flip sim actually, and head back into the fluid initial and watch that, just to make sure it's not bouncing out or anything, you know. Great. Okay, so what else can we do? I'm going to bring this down a bit. That's the actual height of it, you can see. And I bring it up quite high. Maybe a bit less. Let's do bring it down just a little bit there. So the strawberry is actually out of the box, which is okay. If you press spacebar 2, 3, and you can come to this view from the side. I do want the strawberries to actually fall through the fluid, so they won't be actually inside, but this is okay. Should give us a bit of a better splash. Maybe about there. We'll leave that for now. What else can we do in here? Oversampling. So if you remember in one of the other lessons, I'm going to go back to the first frame. We did discuss reseeding, right? Which is, go back to the normal view, spacebar and 1 to go back into your perspective view. We spoke about reseeding, which is where if you have lots of particles pressed into one area, some of them will be deleted, and if you have an absence of particles, they'll be added, right? So if I'm just going to split this left and right again, so we can connect up the oversampling here. And these are both locked, so I can go into my fluid initial here, press P, and turn on the oversampling there, just so it matches what's going on in the actual flip sim as well. And if you take a look at the name of the parameter, oversampling, it's the same as this one, I believe. Oversampling, the parameter name is the same. So you can see the values are different. So in case we want to come back and change this in the future, we'll go to connect and paste relative references. So we got the same thing going on there. In this surface evaluation, we got a similar thing going on. If we turn on the scatter density, this will add more points to the surface. If you take a look at the information there, what it says, scatter points on the surface of the tank, which can help create flat surface for a flip simulation, which is what we want. We want it nice and smooth to begin with. For a value of 1, the scatter points will be approximately separated by the particle separation. So they will trying their best to match this separation. Okay, so we'll leave that there. Let me bring down the layer size quite a bit, so we don't need it quite as thick as that. Bring it right down, and let's bring the particle separation down as well. Can go try to 2. Let's try that. Bring it way down there. Maybe we can push it even to 1. Okay, just get a nice bit of resolution there. And my ocean source also. This is another thing we've looked at previously, this jitter, right? If you remember, if we change this value, it will change per frame. So we can drop in $T there. Previously we used $frame, but we can use $T, which represents time, which is fine. Okay, so on frame 2, instead of 2 here, I'll have 0.041, which is 2/24 well, it should be 24 frames is a second, so it'll be 2 will be a fraction of that, right? Let's see, I think that's all I want to do in here for now. I might come back later. I don't think we want to change anything else there for the moment. We've got a nice bit of resolution there now. Let's try our first flipbook. Could go ahead and do that. Let's make this full scale. Let's take a look at our visualization of this. Turn off the collision guide, it's expensive to calculate. We'll turn back on the geometry. I'll turn off hide other objects. Make this full screen again. And let's try a flipbook of that. Yeah, we'll just do the whole thing. Okay, it's not finished completely, but I've gone ahead and stopped that early because these strawberries come to a rest. So let's watch what we've got. So getting better, still too coarse. We're going to have to bring down the particle separation even more. Be nice to see a bit more of a splash, get more velocity from the collider. Another thing we can see, we got some movement beforehand. So what we could do is not turn on the initial frame. We can turn, if you come here into the flip solver, we go to, where is it? No, sorry, we go out here into the DOP network, the start frame. We can change that so that the simulation doesn't actually start until the strawberries hit the fluid. Other things will, again, obviously we'll want to add some viscosity, surface tension, and a few more bits and bobs as well.